Let's say that I have two vectors written in component form. So my first vector will be u, and its components are u1 in the x direction and u2 in the y direction. And then my second vector is v, and its components are v1 and v2 in the x and y directions. The dot product of these two vectors is very easy to find. You just multiply the x components of each vector together, so u1 times v1, and then you add in the y components multiplied together, so plus u2 times v2. And then if my vector had another dimension, if it were three-dimensional, then I would add in a u3 times v3. But since these vectors are only two-dimensional, I don't have to worry about that. Okay, let's do a quick example to show how easy this is. I'll have my vector u have components 5 and 2, and then my vector v has components 3 and 4. So to find the dot product, I'll multiply the x components together, so 5 times 3, which is 15, and then I'll add in the y components multiplied together, so 2 times 4, which is 8. So 15 plus 8 is 23, and that's the dot product of these two vectors. Notice how this is just a number, not a vector. The dot product of two vectors will always give you a number. Okay, we've seen how easy it is to calculate the dot product of two vectors, but now let's see if we can get an intuition for what the dot product really means. If these are my vectors u and v, then the dot product will be the amount that v goes in the direction of u multiplied by the length of u. So that's this little length times this length. So now that we know what the dot product really means geometrically, we can use what we know about trigonometry to find another equation for the dot product. Let's call the angle between u and v theta. As I said before, the dot product of these two vectors will be these two purple lengths multiplied together. So the longer one is just the length of u, so we can write that down. And now we just need to multiply it by the smaller length. How can we find it? If you look carefully, you'll see that we have a right triangle here, and the length that we want is the side adjacent to our angle theta. So cosine of theta is adjacent over hypotenuse, and the hypotenuse is just the length of v. If we solve for the adjacent side, we'll get adjacent equals length of v times cosine of theta. Now notice that we have two formulas to find the dot product. The top one is called the algebraic formula, and the bottom one is called the geometric formula. You need to know both. And by using both of the formulas, you can find lots of interesting things about your vectors. For example, what if you wanted to find the angle between our two vectors u and v? Just by looking at our vectors in component form, it's not very obvious how we could do that. But if we look at our geometric formula for the dot product, we can rearrange it so that the dot product of u and v divided by the magnitude of u times the magnitude of v is equal to the cosine of the angle between the two vectors. That means that theta is just the arc cosine of the dot product divided by the product of the magnitudes. We already found that the dot product was 23, so now let's find the length of each of the vectors. To find the length of u, we'll use the Pythagorean theorem, so that's the square root of 5 squared plus 2 squared, and that's the square root of 29. And then to find the length of v, we'll do the same thing. That'll be the square root of 3 squared plus 4 squared, which is the square root of 25, which is 5. So theta will be the arc cosine of 23 divided by 5 times the square root of 29. Now, I don't know what that is, but my calculator says that it's 31.3 degrees. Now let's review a few properties of the dot product. First, let's think of two vectors that are perpendicular to each other. If they're perpendicular, then the angle between them must be 90 degrees. And since cosine of 90 degrees is 0, that means the dot product of these two vectors must be 0. Whenever two vectors have a dot product of 0, those two vectors are called orthogonal vectors. Now let's think of the dot product of two vectors that are parallel to each other. If they're parallel, then the angle between them is 0. Since cosine of 0 is 1, the dot product of these two vectors will just be the product of their magnitudes. If we dot a vector with itself, then the cosine term will become 1, and so will disappear. And then we'll be left with the magnitude of the vector times the magnitude of the vector, so the magnitude squared. Hang in there, we're almost done. We can always reverse the order of vectors in a dot product without changing the result. We can also factor out a constant from a vector and then turn it into a coefficient for the dot product without changing anything. The dot product of any vector with the 0 vector is always 0, and that means that 0 is orthogonal to every vector. Lastly, if I have the sum of two vectors, so a plus b, and I dot it with the sum of another two vectors, c plus d, I can do that by foiling the vectors together. That's the dot product of the firsts, plus the dot products of the outside, plus the dot products of the inside, plus the dot products of the last.